Thanks, Armina, for the introduction. So, my name is Susanne Abel. I'm from the University of Greifswald. And as we heard from Armina, the current drainage and the drainage-based utilization of peatlands is not site-adapted and lead to high greenhouse gas emissions. So, the rewetting and the restoration of peatlands can reduce these greenhouse gas emissions, but means most often a loss of agricultural land. But there is also another alternative, a wise solution for degraded peatlands, that it's paludiculture, the wet peatland cultivation or the wet peatland utilization. So the word paludiculture comes from the Latin word palus, what means swamp. So it's the wet use. And this wet cultivation has several advantages. It can preserve the peat body, it can reduce the greenhouse gas emissions, it can produce renewable biomass without competition to food production, it maintains ecosystem services, and restores habitats for typical Maya species. And as it is an innovative alternative, there are not many paludiculture crops available and brought into practice yet. So what are paludiculture plants or paludicrops? So they have to grow in the wet conditions, so they are wetland plants, and they produce biomass in sufficient quantity and quality that can be used for something, and they contribute to peat formation, or at least to the conservation of the peat. And as peat is formed by the underground organs of the plants, only the above-ground biomass should be harvested. So you can either use the spontaneous vegetation after rewetting, or you can cultivate selected wetland plants. So now I want to give you some examples. And I want to start with the most promising plants and the ones that are well studied. Phragmites australis, the common reed. It is one of the important peat-forming species. It is highly productive in peatlands, and it has the advantage that it has an already established utilization chain. So what can you do with the biomass? You can use it, especially the winter harvest, for direct combustion. Here on the right, you see the densified biomass in the pellets and briquettes, or you can use it in several ways as a raw material. Like in Europe, it is very popular for roof thatching, or for construction materials, like here on the left, these fireproof walls or insulation walls. In China, the reed biomass is used for pulp and paper production. And this is the practice example from northwest Poland, where 500 hectares of reed is harvested for thatching. Another promising plant is the cattail. There are several highly productive species like Typha angustifolia, Latifolia oglauca, and they are recommended for sites with high nutrient loads and high water tables. Here you can see the spring harvest in the Netley Livermarsh in Manitoba, Canada, where Typha is harvested for combustion and for nutrient discharge, especially for phosphorus reclamation. So this cattail biomass holds manifold utilization options, but what is so special about it? Here on the right above you can see this special tissue. The erythema is very porous, and this holds very good properties for construction and insulation materials. But you can also use the winter harvest for direct combustion. Several tree species are adapted to waterlogging, and an example from Europe is Alnus glutinosa, the black alder. And this tree is highly productive on sites with water tables from 0 to -10 centimeters. And here the interesting part, the peat formation is high too. Alnus produces high quality timber, and due to the coppicability it can be used as a renewable bioenergy crop in short rotation coppice. This picture sequence illustrates the cultivation trials in a re-wetted degraded fen peatland in northeast Germany, where alder was planted on these ridges here on the left picture, and at the moment the pilot size is in the middle stage. Another promising type of paludiculture is sphagnum farming, the cultivation of peat moss biomass. And this type is applicable on degraded bogs as an after-use possibility for peat extraction or after bog grasslands. And the fresh moss biomass can be used as a substitute for peat in horticulture, and it holds similar physical and chemical properties like peat. And to find other suitable paludiculture plants, we established a database, the DPPP, the Database of Potential Paludiculture Plants, to collect information about useful wetland plants. And until now, we recorded over thousands of species, and we hope that this database will help to find paludicrops for different habitats and climates. And there is also a database for Southeast Asia by Wim Giesen, and this holds information about peat swamp forest species. And especially when you imagine the tropics, there's lots of traditional knowledge about it. Yeah. So the utilization options of these potential paludiculture crops are manifold, and they range from fodder to fuel, food, and medicine, and different kinds of raw material use. And now I want to give you some examples. Here, the natural vegetation can be used as fodder. Here, it is grazed by water buffaloes. And there are valuable fodder species that are adapted to wet conditions. And here are some examples from the temperate zones, like Glyceria maxima. But of course, there are examples for the tropical zones too, like Echinocloa species. And the use of plants as a raw material is very diverse. It ranges from fiber, thatching, stuffing, and here on the right, an example, Juncus effusus, the soft rush, that is used to make these popular mats in Japan. Oops. Oh, sorry. There are latex-producing trees in the tropical peatlands. And here a sedge, Lepironia articulata from Southeast Asia, that is used for weaving as a substitute for rattan, and it has also good potential as a biofuel. Cyperus papyrus, a highly productive species from tropical Africa, that is used as a biofuel. The biomass is compressed into briquettes, and the stems are used for weaving, as a building material, and for paper production. The peat swamp, many peat swamp forest species, like here an example from Kalimantan, hold valuable timber species, like Meranti, Ramin, or Gelutong, that is also a latex-producing tree. There is a high diversity of species that can be used for fuel production, like here on the right, this nice flower, the salt marshmallow, and the seed oil is used for biodiesel production. Or reed canary grass that is already grown as a biofuel in North America and North Europe. There are various food species among these potential paludiculture plants. Here an example, Metroxylon sago, the sago palm, and the starch is extracted from the spongy stem center, and in some areas sago is a staple food for people. And among these food species, there are also several berries, like on the right, the cloudberry, cranberries, but also wild rice. So, as there are not many paludicultures implemented today, we need a lot of courage and effort to bring paludiculture into common practice. And as a source of information, we want to publish a book about paludiculture plants of the whole Arctic, probably in 2015. So thank you for your attention, and you are very welcome to contact me if you have any questions regarding paludiculture plants, and please visit our website, paludiculture.com. Thanks.